Live streaming is
All right, well, hey everyone, glad y'all could make it. Hello to everyone online and in Columbia. Tonight's for the Linux Users Group of South Carolina, the Upstate Carolina Linux Users Group, and the Columbia Linux Users Group. We have with us Matt, is it Friede?
Friede.
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 Friede. Okay, I'm sorry. I should have asked you that before I introduced you. So I met Matt on the Hack Greenville Slack, and he offered to talk about NixOS, and I'm really excited because I've been wanting to know about this stuff. So I'll let you take it away. Thanks a lot.
All right. Hi, everybody. Like Jay said, my name is Matt Friede. I live here in Greenville, and I'm a software engineer at Arista Networks.
Oh, cool. I might do that a lot.
So I work in the NDR group, which is the security product, and there we use Nix for just about everything. It's the operating system that our product runs on. It's our build tool. It's our CI system. We use it for development. It just kind of has taken over everything. And I think it's great. I was introduced to Nix a few years before I started working here, and it kind of bounced right off of me. It's pretty, it's a complicated system, and there's a big learning curve. And yeah, just couldn't stick with me until I started using it full time. But hopefully I can give you guys some information here and it'll be useful and maybe help you guys get over that first hump and jump in and try it. So a quick high-level view of what you get with NixOS. It's a Linux distribution, obviously, and it's based entirely around the Nix package manager. And I'll go into a lot more about what that is. It's a declarative, you have a declarative system-wide configuration. So you have one file, or it can be broken up into multiple files, obviously. But in that file, you declare everything about your system. You got your etc files, your configuration files, what kernel you want to use, everything statically declared in one configuration. It is a source-based distribution. So if anyone's familiar with like Gentoo or something where most of the packages are distributed via source and then built locally. So this gives a lot of fine-grained control over what's on your system and how it got there and how it's built. And actually Nix gives a really powerful caching story. So a lot of times you do not end up needing to rebuild the world when you change things, which can be very painful. And, I've experienced it in Gentoo. It's also kind of advertised as a purely functional operating system. And that's, what does that mean exactly is a little open-ended, and I'll talk more about it, but broadly speaking, I mean that there's no mutable global state. So like you install a package, it's never going to clobber right over files that were installed by some other package. They're all kept completely separately. And that gives you a lot of power too. And also the packages built themselves follow a functional design pattern where every build is reproducible. Every output is exactly the sum of its inputs. And if you put the same build inputs in, you get the same build outputs out. So this talk is not intended to be a how-to guide. Like I said, Nix is a very big topic, and it has taken me a long time to wrap my head around it. So I'm just trying to give an overview of kind of the Nix philosophy and a little intuition behind how it works and what makes it unique and why you should give it a try. Quick sales pitch on what some of the good things that this brings for you. I think definitely the biggest one is the reproducibility. Like I said, everything is purely defined. All of your inputs are captured, and so everything that Nix builds is kind of reproducible by default. The packages you build, your build environments you can set up. It's really nice for having everyone on your team make sure you've all got the same version of every tool and every library that you all are using. And with that, you get really easy system rollbacks because, like I mentioned, it's never clobbering any existing files when you install something new. So the old one is always there and you can easily switch back to it at any time. And in the same vein that avoids any version conflicts, you can install multiple versions of the same library at the same time. You can have multiple versions of glibc and it's no problem. It doesn't blow up your entire system. This one is just one of my favorites, is using packages ephemerally. So by that, I mean, I can install a package and I use it in this shell session. And when I exit that shell session, that package is no longer in my environment. So it's great for the one-off tools that you just need for to do this one little task, and you don't want it to pollute your environment, because whoever goes back and uninstalls a package after after they stopped using it.
So when you use something, does it build it immediately and then remove it then whenever you're done?
It's not quite removed. It's removed from your environment when you're done.
Okay.
It's still going to be on your machine.
Okay. You said caching though, didn't you?
Yeah.
Okay.
Yeah. I'll talk a bit more about kind of how that all gets stored.
Sorry to interrupt.
No, that's fine. But it's not going to be on your path or anything. For all intents and purposes, it's out of your hair. Oh, and just the Nix packages repository is over 80,000 packages, which is one of, if not the biggest package repositories. I think like the Arch repository might have more, but it's a very big repository, so it's got pretty much every package out there that you would need. And just, I mean, the list goes on. Is good for cross-compiling, great for CI, a lot of good caching. We use it to build Docker images. We also just straight up replace Docker with Nix images as well. So it can just do a lot of cool stuff. So the first confusing thing about Nix is, what is it? So I stole this picture from Reddit, so forgive the spelling errors. I wasn't gonna fix it. But Nix is a bit infamous for its confusing jargon, so I'll try to break it down. And the first confusing point is that Nix tends to be a pretty overloaded word, and we kind of have these three core components. There's the operating system, the NixOS that we're talking about here, the package manager, and then the language Nix that you use to configure all of this. So just briefly, each of these three, Nix, the package manager, is similar to other package managers like a apt or a homebrew, yum, to install packages on your system. We call it a package manager because it's closest thing to something people are probably already familiar with, but it's a much bigger tool that can end up doing a lot of things, and even replace like a kind of the role of like make files in a sense. And you can also use this package manager without actually using NixOS. So you can get a lot of the benefits of all of this stuff that I'm going to be talking about just using this tool without fully committing to the OS. Then there's Nix, the language. I like to call it a configuration language. I've heard it also called an expression language, even a full programming language. I heard someone did advent of code in it, so I think it's possible, but that's not really advised. It's the language that all of these declarative features I've been talking about are declared in. It's a functional language. It's lazy. I think those are the two main components. And so essentially what you have for the language is it's lazy JSON with functions is the closest description that I'm going to get. I'm not going to spend very much time talking about the actual language because that's a whole other talk that you could give. So
we should expect you back in a couple months.
Yeah, I can do that. So when it will show up, we're just going to kind of hand wave around it, and just going to have to trust me that that's how it is. There's going to be a lot of hand waving, and trust me in this talk because it's just too much to go over.
Yeah. We only have an hour.
And then, finally, just the operating system, right? That's an operating system built around this Nix tool, and just takes the whole philosophy to the extreme of treating your entire machine setup as the package, basically. Let's see. So, since the whole thing is based around the Nix packaging manager, I figured it'd be important to start with a little talk about package management. So, package management is really the core of everything in Nix. And so here is just a really simple model of how we look at packages as pure functions. And kind of tying back to the purely functional description from before, we look at the package building process as a pure function from its inputs to its outputs. And so your build inputs can be anything from your dependencies, your source code, configuration files, whatever they might be. And then we run them through some build steps, and that creates our build outputs. I have listed here executables and libraries because that's commonly what you expect from a package manager when you install something. But it could be anything. You can output a Docker image, a shell script, more source code, other configurations. And so the key point here is that given these inputs and these build steps, we'll always produce the exact same outputs. And Nix takes this particularly seriously. So even if a package is installed on your system, but it's not called out in the package's inputs, your build will fail. It won't be available during build time if it's not explicitly called in the build inputs. So this gets rid of the whole works on my machine setup because every dependency is accounted for. And speaking of dependencies, all software is essentially a dependency graph. And there's tons of dependencies. This one I have here, I just generated from NeoFetch. And this is even just the runtime dependencies, because the build time dependencies I couldn't fit nicely onto a slide. But that's, where's that? Sorry. So this dependency graph shows all the dependencies for the running executable. And these relationships always exist, even outside of Nix. It's just that Nix forces you to be explicit about everything, whereas your machine in another system might just trust that you've got the right version of the right library in the right place. Nix gets rid of these assumptions and forces you to make all of these relationships explicit. And they are so explicit that you can run them through image generating and view all of your dependencies like this. So where does Nix keep track of all of these packages and all these dependencies? It keeps them in the Nix store. And this is on any system on NixOS, and even if you just install Nix in a different OS, it'll be at the path /nix/store. And what we have in there is a bunch of content addressed entries, really. They can be anything from actual files to entire build systems, derivations for building. I'll talk about derivations in a second. But the key thing there is just that everything is prefixed with a hash to uniquely identify it. So even if you just change a build flag on something, you could have two versions of the same library in your Nix store, but they'd have unique hashes. So you'll know anything that was depending on the old one will continue to work. The old one's still there, because they're all uniquely identified with these hashes. And this Nix store is an immutable record. Once something is in the Nix store at one of these addresses, it's never changed. So you can always trust what is in there. And since they are content addressed, whatever is on my system at this particular hash is going to be exactly the same as if you had this file on your system at the same hash. And this is essentially creating a graph database of all of these entries in the Nix store, and in each entry it contains references to other packages that it may need. And so you have essentially just a graph database of all of the packages on your system and how they relate to each other. So I mentioned a derivation. This is going to be a lot of Nix jargon, so get ready. So a derivation, this is how in Nix we represent this functional build process. The build steps are all represented in what we call a derivation. So you start off with a Nix expression and you instantiate it, which is just the word they picked. And that more or less compiles, you can think of it as compiling your Nix code into a derivation. And this derivation is the entirety of everything needed for that build. So it has your build inputs, it's got the build steps, it is the representation of the complete build process. And then you realize a derivation to actually build the output. So essentially run that build plan that's contained in that derivation. So instantiate creates a derivation, and then you realize a derivation to create the outputs.
So the derivation is in that Nix store?
Yep. Yeah.
And I assume the Nix expression is in the Nix language.
Yes.
Okay.
Is written in the Nix language. Yep. So if you can see here, there's a few .drvs in the
Gotcha.
Nix store. Those are the derivations. So those go in the Nix store right next to all the build outputs.
Oh, interesting.
And I guess I didn't mention, but this is relevant. Only the Nix tool ever writes to the Nix store. It's pretty well guarded from an ownership perspective. Okay, so we're going to just do a little example to go through this build flow here. So the example is going to be, we have a Python file and we want to produce a standalone executable. And don't get at me about putting a shebang line on there or something. We're just going to pretend that's not an option. And there's plenty of reasons why you wouldn't want to do that anyway. So here we've got our file, greeter.py. Very simple, just prints hello and whatever the argument you give it. And there's an example of it running. So that works, but we don't want to distribute that. So it means we have to make sure that other person has Python installed, and we don't want to trust that. We want something that's going to be reproducible. So we know that what we want for our output, for our build output, is an executable that will perform this task. So here is our first Nix file. This is the Nix language. Like I said, not going to go into detail how the language itself works. But you can see roughly we're binding Nix packages, we're importing Nix packages, and that's giving us a reference to the entirety of the Nix package store. Since it's lazy, we're obviously not actually downloading everything. But that's kind of what that represents. And then we're going to bind our source file to this greeter.py. And then we're going to use this helper utility called write shell script bin, that all it does is it creates as its build output a shell script as you describe in it. So the first argument there is greeter, that's just going to be the name of it. And then what comes next is the shell script that I want to create, where I put in Python as a relative path off of the one from Nix packages. So that's going to give me a hashed version of Python in my Nix store that I know is going to be there. And I'm also going to splice in the file, which itself is going to end up in the Nix store and pass the arguments in. So we're going to instantiate that file, and that produces a derivation. The big hash, greeter, derivation. So what is in this derivation is our source, what we need, all of our build inputs, as well as the build steps. So I'm going to pull back the curtain a little. What all is in here is not really important. I'm just trying to drive home what is a derivation, because I don't know, it was very confusing to me because it doesn't map to anything that it would all be familiar with from anything else. So what I display the contents of the derivation just to show you that in there is references to your source code, which is now actually in the Nix store. All of the build dependencies in there, there's Python 3, you need Linux standard env, I don't know what that is, and you need bash because we're putting in a bash script. And then at the bottom, again, it's a bunch of gibberish because it's a script all mashed into one line, but it's a bash script that creates our build outputs. So that's what's in a derivation, is hashes to everything that you need for your inputs, how to build it, and a bunch of other stuff. But okay, so if we then realize this derivation, it actually creates our build output, and it tells us the new hash where the build output is stored. And if I run the executable at that build hash and I give it my name, it prints out a nice greeting just like we had hoped. So, and here I'm showing what actually is in the script that it created, just to kind of drive home that everything gets put in the Nix store and that everything is content addressed. Your shebang line is a hashed version of bash, big hash for what version of Python you're using, and you've got hashed stored version of your Python source code in there as well. So every file that we've mentioned ends up hashed and stored in the Nix store. And that's how we end up with all of our reproducible properties. So the last note of jargon kind of on this is there's a shortcut, you call it just a regular build, is the process of going from the Nix expression to the build outputs. The breakdown can be important is useful for a lot of things, but the main one that jumps out to me is when you instantiate a Nix expression, it will populate your Nix store with all of the dependencies that you need. So if I didn't have Python on my machine, that instantiate would have made sure it was in the Nix store. So it gets all of your dependencies ready. And this is very useful for remote builds. Since everything's content addressed, you can instantiate your Nix expression and compute essentially the entire set of dependencies that you need. You create a whole closure for those build dependencies, move them over to a remote system and have it build there. So that's a lot of how you can do cross-compiling easily, or I just have a more powerful machine at work that I send all of my builds to because it's faster. So the breakdown between just building and the two ops is useful for a lot of things.
So if you do a build, does it not create a derivation?
No, it does. It does. The build does. It's a shortcut of typing it out. You know. But like I said, the breakdown comes in handy for a lot of things. Okay, actually getting to the operating system itself now, NixOS. So, like I said before, everything on your system gets described by a Nix expression. So your kernel, what packages are installed, your etc configuration files. And here I've got a selection of just some random chunks from my Nix, the configuration.nix on my system. And you can see there using systemd boot. We got the EFI mount point. You define your users and what groups they're in. You can define what packages are available, particularly for that user. And then below, you've got the environment system packages, which are packages that are available for everyone. Setting all kinds of settings, your time zone. And then I've also got my configuration for the NVIDIA graphics that I use in there. And so this could go on. You do your firewall settings, you can make systemd services, but this ultimately gets turned into a derivation too, just like in the Python example. The build steps are going to be quite a bit more complex, but the intuition is exactly the same. For example, one of the build outputs that will result from this is going to be an X server configuration file to support the NVIDIA settings that I put there. So it's a little small. at the top, the details don't matter, but I'm looking up the X server that's running on my system. And first of all, the executable that's running is from the Nix store, and it's passed an argument giving it the configuration file, which is also in the Nix store. And if we look at what's in that configuration file, there is in fact an entry for a section with a device using the NVIDIA driver. So it pulled all that together for you. You just need to configure it in that one place in your configuration.nix. So what does that get us when we put it all together? So building the configuration.nix, the actual output is a new system that ends up in your Nix store. And this system is kind of like a root file system. It's a big kinda, but we can look at it here. I've got a few examples. So there's the bin directory from one of my system outputs, right? And it's got all of the executables you'd expect in a bin directory. And if I look in the etc directory, there's a bunch of configuration files. So it builds something like a root file system. But then the trick is that everything is just a symlink. So just somewhere else in the Nix store. So our bin, in that bin directory, everything is a symlink to somewhere else. The etc directory, the whole directory is just a symlink to an etc entry in the Nix store. So again, kind of what I said before, everything's in the Nix store, all held together with a magic web of symlinks, and that's what constructs this graph of all of your software dependencies.
Now, I noticed that it says NixOS system, NixOS 22.11.1777. Is that the version of NixOS?
22.11 is the version.
Okay.
I don't know where it came up with.
Some other hash or something.
Yeah.
Okay.
That's the particular generation of my system that it just built.
Oh, okay, gotcha.
Yeah.
Is that kind of a year, month?
The 22.11 is, yeah.
Gotcha.
And it's on a 6-month stable release cycle. So
cool.
And then of course there's a bleeding edge, unstable channel that you can subscribe to and get all the latest versions of whatever you want. So where was I? Yeah, so everything in there is just a symlink. So this gives us something pretty cool where every time you change that Nix configuration, it generates an entirely new structure for your system. And we keep track of these as generations. And so here's a screenshot of the bootloader where it knows about all the past generations, and you can boot straight into a previous generation. This could be really useful if you ever tweak something and really messed it up with your video drivers or something, and you can't get it to load. And you can just roll back from the bootloader. Right, because the previous system objects are all still there. And this gives you easy rollbacks. Let's see. Oh, and I guess I should note, like, you can have all of these system objects, but since everything in them is symlinks, most of it is shared. So you're not blowing up your system with duplicate copies of everything. As long as the hashes are the same, it can all be shared between all the generations. So now I'm going to talk quickly about a cool tool that actually somebody who used to work with us built.
Oh, cool.
But is a tool, NixDiff, and it gives you a detailed diff between two derivations. And this has been incredibly useful for various things, mainly cache miss. Right? Like I said, Nix obviously has everything in the Nix store, content addressed. So if you try to build something and you expect it to already be there, but it starts building, you can investigate why, like, what changed, why did it think it needs to rebuild instead of using something that's already there. And it can give you, it'll tell you exactly what changed. So you don't have to worry anymore, like, I swear I didn't change anything. Like, you can see exactly what's changed. And you can also figure out why your system worked yesterday and doesn't today. This has been handy for me plenty of times because we run like our production systems on NixOS, and we have internal systems that it's kind of like dog food, right? Use your own system so you can make sure it works. And so it's kind of a free-for-all in there, developers changing things on a whim, and all of a sudden the thing you're working on doesn't work anymore. You can look at the generation history and NixDiff between them and see who changed what. So that's been very useful. So just a small example using that. Say on my system that I didn't have SSH enabled, and I wanted to turn it on. So in that configuration.nix that we looked at earlier, I just set OpenSSH enabled equal true. That's nice and straightforward. Then I apply my configuration with this command. Is how you apply the system configurations, because obviously it's going to be a little more involved than the other one. So there's a tool that manages all that for you. And so we apply that system configuration. And now with NixDiff, I can compare, see this path here, Nix var, Nix profiles, system 13. So 13 was the 13th generation. That was the one before. And then run current system is the closure for the current system. And I can just NixDiff between them, and we can see what comes out. What comes out is actually a lot. So I'm just going to be broken up in just a few sections of it. So from here, the output derivation for our etc directory changed, and now there's some new entries in there: SSH config, SSH pam. So we know we've got that. Let's see. In our firewall script, there's a new entry allowing port 22. So that's nice to know that works and that it's all handled automatically. But it's also good if something's not working and it's because someone changed a firewall setting, and you can find out who did it. And finally, we've got a new group was added. This one's kind of hard to read because it's a bunch of text for all of the groups. But there's a new SSHD group in the list. So that's just a small example of what like NixDiff can kind of show you, and how it can highlight differences and make tracking that stuff down really easy. We've tracked down production issues using this multiple times, and it's been a lifesaver.
And NixDiff is now part of the proper Nix system? Or is it still an internal tool?
Neither. It's a package you can just you can download and use. It's in Nix packages, so from Nix you can just pull it up. It's one that I usually use ephemerally. I don't just keep it around. But so yeah, so anyone, it's out there for anyone to use, but it was just developed by someone internally. I think it's even on their personal GitHub. It's not even like our company's. But Yeah, so that was kind of all of the highlights that I wanted to talk about. Like I said, there's too much to go over everything. I was just trying to give a little taste of kind of how Nix works and what benefits it can bring for you. And like just to finish off, it's purely functional. I hope we got a little better understanding of what I mean when I say that. You have declarative system and everything is reproducible. So that's the end of the slides. I'd be happy to take any questions if there are any, or we can end here. We can pull up Nix and play with stuff. I don't know.
Do you have Nix on that system?
Yeah, I got it on here. So it's not NixOS, but I have the Nix tool on here if you want to.
Are there any questions from anyone online or in the room?
Yes. Is NixOS based on a Linux kernel?
Yes.
In what way do you mean that, Ben?
Is it using the Linux kernel?
Yes, it does.
Okay. Well, that's what I want to know. Great.
I guess if you use it as a physical or virtual machine, then yes. But if you put it in a container, then not necessarily. Or if you put it, you got it on the Mac, right? You're using Nix. You're not using NixOS. You're using
Right.
Nix package manager, Nix language.
Yes. Yeah, if you're just using the tool, then the kernel doesn't have to be involved, but NixOS operating system runs on the Linux kernel.
And just one of the packages, I say, right?
Yeah, you specify it in your config, what it should be.
Okay, so that was super cool. Like the bootloader thing is, I can't tell you how many times I've had to use a rescue USB, so like the idea of never having to use a rescue USB again, it's very appealing. I guess my question, so are you guys you're using this at work, and I'm assuming you're using it with your deploys. Are you still using Docker with NixOS, or how did it like replace Docker, I guess?
Yeah, so we still have Docker, but it's more of our older systems. The newer ones we don't create with Docker so much anymore. So like on our production system, we keep things separate via services, and everything's just defined, configured via Nix, and we do run some Docker images on there as well. We still generate Docker images for things like cloud services, running something in a AWS Lambda, for example, and actually generating your Docker images with Nix tends to get them smaller than using a Docker file, because Nix tracks all of the dependencies and runtime dependencies, so it copies exactly the runtime closure of all the dependencies that you need.
Okay.
Yeah, most of our existing services or any new services we make, we don't put in Docker images, but we support the existing ones.
So do you like have a C group set up, and then inside this C group you put a Nix OS or something like that?
Pretty much everything runs as systemd services. All of our internal services.
And systemd takes care of your C groups and stuff.
Yeah.
Okay. Oh, interesting.
Okay, so it sounds like you can use NixOS to generate a Docker image.
Yeah, you can.
Okay, but you can also just, like, you were running it on your hardware directly when you're using the bootloader. But then, like, how do you guys deploy to, like, do you deploy anywhere with like a Nix?
Yes. How we actually do it is you can go from a Nix configuration to an ISO, and that's what we do. We generate an ISO, and then we put that on our machines.
Okay.
And then the only thing else, we just recently started doing stuff in the cloud, and we deploy things there. Like I said, mostly in containers, so in Docker images that were generated with Nix.
The ISO, you boot it on your hardware and then it does the full install? And so is that recompiling everything? Or does the ISO include the compiled output of your configuration?
That's a good question.
We-
I'm not on that team. That's someone else.
That's not
Let's see. We do have a.
It would probably have the store in the ISO, right?
Yeah, it would. It's not rebuilding everything that's on there. I think it lands somewhere between all the like core systems, and everything is installed and is on there, and then we have something that we distribute additional files to these machines through a Nix channel, which is another topic that I didn't touch at all. But it's essentially like a repository, a way for it to access the remote files. And so we distribute some configuration files and things after the fact to the machines through that. But for the most part, for everything to run, it's all on there in the ISO. And we've got to go through great lengths to make sure none of our source code accidentally ends up in there.
Well, Matt, this is the most important presentation that I've seen in UC Lug and Cola Lug history since Docker was presented in 2014. This is really phenomenal.
Yeah, this is amazing.
Glad to hear that. Thanks.
It kind of reminds me, I'm trying to think of there was another like fake distro that you could put on top of your other distro many years ago. I think it started with a G.
Global Linux.
What was that?
Global Linux?
Yes, Gobo Linux. Yes.
Yeah.
It reminds me a lot of that. Well, in some aspects of it too. But this is cool. Yeah.
I was reminded of that also, Jace, while he was talking, because Global Linux had that same idea where you could have different versions of the same package all on the same box, and it was all managed by the file system instead of having
Symlinks and stuff. Yeah. And you could have it in your home directory.
right.
Yeah, that was kind of cool. Well, that's great. Any other questions? Anybody else out there?
Any good links or resources that you would recommend, or books or talks or whatever?
Yeah, that'd be a good thing to add here. But
Well, there's obviously NixOS.org.
there's manuals on there that's very dense. You can read that if you want. There's a website. I don't know if the name of the website is Nix Pills.
Pills.
Oh, they even have a link to it from the NixOS.org. So from the NixOS.org site, and there's guides. There's Nix Pills, and that
Could you say?
I don't know where. Put that in
You
the
need to
chat.
stop sharing first.
I'll put it in the chat. There you go, chat.
And so this is kind of a step-by-step guide that walks through setting up Nix, making your own derivation, and all of that kind of stuff. So this is more of the guide if you're looking for that.
Okay. So these pills were easy to swallow, I guess? Small little explanations.
Yeah, I think they do a good job. Like I said, I tried to learn it the first time and it didn't stick for me. I think the documentation has obviously gotten a lot better. This was like on just someone's random blog or something, but looks like enough people liked it that they moved it to the homepage. But yeah, it's a steep learning curve with a lot of jargon, and it's definitely not one of those where you can get by without getting your hands dirty. It's not just perfectly all abstracted away from you. You work with it for very long, and you'll need to dig in to understand why something is the way it is. But like I said, I've been converted, since using it for work. I now run it on my personal machine at home for everything. And it just starts to feel, I don't know, once you get used to it, the idea of just installing random packages and losing track of them just feels bad. I guess.
Right, yeah. That's cool. Fantastic.
But I'll tell you, the big hook for me is being able to generate the smallest possible Docker images or container images using Nix as my first priority and major hook into the operating system right now.
Yeah, that's great. That's a great use case. We take advantage of that a lot. And the whole it being able to differentiate between the build time closure and the runtime closure is really nice because you can copy closures between NixOS machines. So if there's a package on my system and I want to use it on a different machine, I can copy the closure for that package, and it'll move not just that entry in the next door, but all of the runtime dependencies for it. It'll also copy over. So it's just a much more kind of robust version of SCP and your executable over there and hoping it works.
So, all right. So you had mentioned also that whenever, as you're using it, it will get, and you stop using whatever executable, it will be removed from your environment.
Yeah.
And I'm assuming that's done seamlessly, right? Or, do you think you could demo that?
Yeah. That's a pretty easy one.
So if you could
Did the
share.
meeting start?
So he's about to share right now.
I do all of I live inside a virtual machine. I had to pull that up. Okay. So here's just a show.
I had the whole time.
What's that?
Nothing. I was just had the camera on the whole time and didn't realize I had tape over the camera lens.
So let's like Python is just a common example because it's confusing which version of Python you mean. So I don't actually have Python anywhere in my normal profile. But if I do Nix shell -p Python 3, this will drop me into a shell. It's got to download some stuff. Apparently I don't have Python 3 on the system.
That's weird. And this is just a shell on your Mac?
There we go. Okay, so first of all, that's how long it took for me to get it, because I didn't have it. And now when I run it, I do have it.
Okay.
And so, then if I exit the shell, right, it's gone again.
Okay. Oh, interesting.
But if I go back in, I shouldn't need to download anything this time,
Because it's cached
right?
into the store.
Yeah. So, and that command nix shell is how we also do like all of our development environments. So this one just -p Python pulls in Python, but you've got a whole description of all of the build dependencies for like what you're trying to build, right? Your build tool. And so you drop into that nix shell, and all of a sudden I've got all of my build tools that aren't just around in the system.
What does the -p stand for again? So,
Package, specify what package.
so could you like define, say, my build environment, let's say Jason's build environment, and that becomes a package then? So you'd say Nix shell -p Jason's build environment, or would I have to like go into the shell, add Python 3, add my this and that and libraries and other tools and stuff inside of that Nix shell?
So if you wanted to make a build environment that had whatever packages you want, you would write it as a Nix expression. And there, the standard is shell.nix. So if you actually do Nix shell without any arguments, it will look for the nearby shell.nix and load whatever's in there. So
In the current directory?
Yeah.
Ah, okay.
So that's what all of our, because we have our system for work is a mono repo. We've got a lot of different languages used.
Yeah.
So in each package, you can just go into its directory, Nix shell, and you've got all of the build tools for that.
Oh, wow. Oh, wow. Wow. Okay.
Yeah.
All right, mind blown. That's cool.
Yeah, there's a lot of black magic, but when it's all working, it's very cool.
Once it's working, yeah.
Have you ever had the black magic break and have to go dig into the internals?
Yes.
Or is it bad, or is it well documented? Is it discoverable, or is it just like so much black magic it's who knows what's going on?
There's
Wipe and reinstall.
Well, I haven't got to the point of need to wipe and reinstall, but no, I wouldn't describe a lot of it as particularly well documented. And so, like I said, if you do find yourself in a situation like that, you do kind of have to go spelunking. I've got the Nix packages GitHub page bookmarked. They do have, they've recently made it some nice new search tools that do help find some stuff. But still a lot of the, for NixOS in particular, you know, at work, it's all homemade anyway. But for NixOS, like a lot of the stuff I showed in my configuration.nix file, like that stuff is all pretty poorly documented. So there's not really a good way to be like, oh, you know, I want to turn on SSH, right? And I showed the line that you would add. there's no way you would know that's the particular line that you need to add, like, pretty much without just Googling it.
No, that's great.
So you gotta have a little grit to get around some of those rough edges.
So one thing that I was curious about is, you're talking about the configuration dot, what was it? Dot net?
Configuration.nix.
.nix?
system.
Does it take like a configuration.nix.d so that you can have a directory with multiple files instead of one huge file? Can you break it out?
You can break it up.
Okay,
Yeah.
okay, good.
It's a whole.
Because good golly, if
Yeah.
if I have a huge system and, I've got tons of users and I've got tons of network configuration, I've got tons of packages.
Yes. I mean, we have thousands and thousands of lines of Nix over a lot of files to describe our entire build system.
Okay.